after 3, shift 0 to close the bracket, hit enter. Let's do the same for the fourth quarter. Shift 9, open the bracket, control. Let's go to the fourth quarter, there, fourth quarter, there, and fourth quarter, there. Shift 0, hit enter. So, I'll show you where in this case we're going to assume that these specific seasonal indices are just okay to reduce the complexity. But if you add these numbers and they're not adding up to 1, then there's nothing wrong with what you've done. But in that case, then you'll have to introduce what we call the deflection factor. Yeah, you'd have to introduce what we call the deflection factor. Did you look at the deflection factor in class? Christopher, confirm that.
I think we did with you, Mr. Matabu, but not during the lectures.
Oh, okay. So we use the deflection factor for the sake of accuracy. Okay. We use the deflection factor for the sake of accuracy, where you find the more like a percentage by which these numbers are like the percentage in terms of differences, and then you multiply that by each of these numbers. When you add those products, they'll give you a 1. So to reduce complexity, we are going to make an assumption that everything is ceteris paribus. Alright, because basically what I'm showing you is how to use Excel to do the forecasting, to do the exponential smoothing, and then you make your forecast. Okay, so what do these numbers entail? Remember that we are looking for a specific seasonal index. A specific seasonal index. That's what we're looking for. And the importance of that specific seasonal index is that we want to understand the impact of just the seasonal component. Okay? And we want to understand that particular impact for each particular quarter of each particular year. Right? So what we're going to do now is to copy these numbers, hoping that we will not have complications. Okay. So when you have this error, it's because the formulas are not here. Okay. So what you do is just get them 1 1. So you copy that, you paste it in the first quarter. What's going on? Okay, that's 1.009754. What mistake have we done? Were we supposed to lock something? But these are numbers. Why should we lock numbers? Anyway, let's just paste them here to avoid complications. 0.862488. Then I'm just going to copy them and drop them when we have put them here. 1.093349. Okay, sorry, 9. Then the last one is what's going on? Then the last one is 1.143305. So what we can do now is just to copy these and then we paste them everywhere. As simple as that. Okay. Alright, so now, what are we seeing? What we've done is check the combined force of season and regular component is just showing us the combined force of these two components in quarters starting from the third quarter of 2020 to the second quarter of 2023. But how about the other quarters? Okay, so now what we do is to associate each quarter with a specific component. We isolate the seasonal component so that we understand the impact of the seasonal component in terms of the sales in each particular year pertaining to each particular quarter. Okay, so how do we give the interpretation now? You say in for instance, which one? Anyone. We can pick any. Let's pick this one. Third quarter of 2020. Okay, third quarter of 2020. The impact of the seasonal component was or is 9.3% above the baseline. Get me right. In the third quarter of 2020, there was a 9.3% increase in our sales because of the seasonal component. So which means that the 9.3% is the contribution of the seasonal component to the increase in our sales. Okay? The 9.3% increase in our sales came from the impact of the seasonal component in this particular quarter of 2020. Okay, let's pick this one. Okay, so in the second quarter of 2022, there was a 14% reduction in our sales because of the seasonal component. Or in other words, seasonal component led to a 14% reduction in our sales in the second quarter of 2022. Okay, is that perfect? Are we all alright? Should I repeat? Okay.
You said that when it starts with one, it's an increase.
Yes. Yes. Correct. Okay.
And then, why is saying there's a 14% reduction?
Because this is 0.86. I'm talking about second quarter of 2022. Second quarter of 2022.
Okay.
It's a, yeah. Okay. I believe the wind has been cleared, the air is clean, right? No clouds, no nothing, right? Okay. Perfect. Meaning that we can go ahead and do the deseasonalization. Okay. Is this fine so far? Cooking, no question, no nothing. Okay. So now let us deseasonalize. So now to deseasonalize is to completely remove, because what we are doing here in the specific seasonal index was just trying to understand the impact, right? To understand the impact of this seasonal component to our sales in each particular quarter. But now what we want is to completely remove, or what we want is to smooth out. So we want to remove the impact of that seasonal component. We'll remove it so that we see how our data is going to behave without the seasonal component. Alright, remember we're dealing with a multiplicative model, not the additive model. I think it's the multiplicative model. So we know that the normal time series data must be this and I, right? Where I is the regular component. This is C. So if we want to completely remove the impact of the seasonal component, we know that what we can do is just divide everything by the seasonal component, because that and that will go, which means that we have removed the impact of the what notice. Sorry guys, let me just check what's going on with Ozabeka. These guys are just now, they're getting under my nerves. Hmm. 2030. Okay. Oh, sorry. Yeah, so what we want is to, when we know that when we divide, it's more like we have 2x squared, right? When we divide this by x, we know that we're going to remain with the just 2x. So that's the same logic we're using. We are dealing with a multiplicative model here. Oh, sorry. So we know that the moment we divide that model by, because it's more like we are saying y is c multiplied by t multiplied by r and multiplied by I. We know that if we want to what's this? Okay, let me put s there. Okay, so you know that if you want to isolate s, you're just going to divide by s. So that this s and that s vanishes. So that we have got c, t, and I. Okay, which means that the seasonal component is gone, right? So the seasonal component is gone by just having this model without the seasonal component. So that is what we call deseasonalizing. Okay, we want to deseasonalize, we want to remove the influence of the seasonal component. So how do we do that? Let me put the formula. Oh, hold on, mistake number 4. Okay, so the formula is that divided by the ST. Okay, let me use the uppercase and then the lowercase. So where the ST is the specific seasonal index. So let me say that can also be that. Okay. Alright, so that is what we want. Okay, so we want to deseasonalize. So we know that the YT is our actual cell. So that divided by this. Okay, we hit enter. So what I want you to notice is that this was our actual cell, 4.8, right? And then we said that there was a 9.75% like the impact of the seasonal component. So now, after deseasonalizing, okay, I really want you to understand this. After deseasonalizing, or after removing completely the impact of the seasonal component, our actual cells is 4.7, not 4.8. I don't know if you're seeing the difference there. So that point something percent, okay, that led to 4.8, like the quantity of whatever thing that was sold is attributed to the seasonal component. So what we want now is to remove the influence of the seasonal component. That is why the deseasonalized value in this case is less than the actual value. Because, so now in your recommendation or in your interpretation, let me say so, you can say that from the table above, it can be shown that after deseasonalizing or after completely removing the impact of the seasonal component, our sales are actually 4.7, not 4.8, meaning that the 9.75% increase in our sales was due to this seasonal component. Are you getting that one? I just want someone to confirm. Sandra.
Yeah, I'm getting.
Okay. Anyone who is behind on that? Anyone who is behind on that one?
I think it's quite clear, but I'm a bit confused on when you interpret it in percentage form, when you said 9.7% increase.
Okay.
Is associated to the seasonal component.
Okay, I believe that is Peter. Okay, so what's going on is that we are trying to understand the ratio of the actual sales to the specific seasonal index, right? So what we are saying is that, as you can see, here we have got 4.8 as the actual sales. Remember, these are in thousand, so you can say 4,800, right? So you have recorded to say we have sold quantities worth, or we've sold 4,800 pieces of whatever products that you're selling. Let's say chickens. So you have sold 4,800 chickens. But what you're not understanding is that there is some reason as to why you have sold 4,800. So that reason or that factor that has led you to sell 4,800 is the seasonal component. Alright. So what you want to understand now is, if there was no such a thing as the seasonal component, how many chickens would I have sold? That is why we are removing it. We are factoring it out. So what you are seeing is that after factoring that particular thing out, you will have sold 4,754 chickens, not 4,800. Meaning that there was a 9.75% increase in sales of chickens because of the seasonal component. Is that fine now, Peter? I believe that was Peter.
Yes, it's clear. Thank you.
Okay. Yes.
Yeah, sorry, just there. Where you are saying 9.7. I thought we are subtracting 1, then multiplying by 100, meaning the 0 will just move to 0.9.
Oh, it is 0.97%, sorry.
Okay.
Yeah, sorry. Thanks for that. Okay, but the interpretation does not change. Okay. Yeah. Alright, so we can then use the fuel handle. With all that being said, we can use the fuel handle to drop everything. So this becomes our deseasonalized values. This becomes our deseasonalized values. How come I've got a column here? Let me move this to this side and just cut them. Alright. Now, yes. Someone's mic is on. I assume you want to ask something.
Sorry, that was a mistake.
Oh, it's fine. It's fine. Alright, so now let's get what we call a trend. Now, we have done regression in class, and I think we understand that with regression, there is what we call the trend line. That trend line gives us the general direction or the general behavior of our data. By this I mean, has our data been increasing or decreasing? the trend line is going to give us that general direction of our data. So what we want now is to find the beta naught and the beta 1, which will then give us the trend. So, in mathematical terms, okay, in mathematical terms, what I'm talking about is this. Where is that? Symbols? No. Text? No. Symbol? No. Not this one. What is that? Okay. Is it control S? Control what? I've forgotten the shortcut. Now it should be here. Here. Nah. Which way is the insect? Can we come to this one? Let's drop that. Do we have that? Okay, I've got none of the templates given. No problem. No, not here. Okay, to avoid complication, what I'm talking about is this. I wanted to use but we can still do that. Let's go to symbols. Go to symbols, we go to beta. Do we have beta here? Or maybe it's on top. Just a minute, let me just peruse through. Okay, beta is right here. I don't know why I wasn't seeing it. Okay, so we have got beta naught. Then let's go to home. You come here, and then you come to subscript. Click OK. So beta naught space plus. No, not in that. So this is where the complications comes in, especially when you're putting in mathematical. So what we can do to avoid complication is just to copy the beta and then you paste it here. And then you go back to here, you go to that, put a subscript, you put a 1, and you go back to remove it. These messages are now watching me. Oh, yeah, so we put a small letter T there. What's going on? I'm alright, don't worry. Okay. Alright, so what we want is to have this thing here. Okay. That's exactly what we want. So, never mind, I'll take it back. What we want is us to come up with this formula. In economics, I think I used to the consumption formula. Consumption is equal to autonomous consumption plus, the marginal propensity to consume multiplied by the level of income. That formula, what you'll be doing in third year econometrics is to, find that particular formula using regression. Okay, that's what you'll be doing this year. Because they believe that you guys are now old enough, mathematics-wise. Okay, so that's what we want to get here. So this is what we want to get, right? Alright, so let's do that. So that's why I said you need the 2-pack. So go to data. Okay, go to data analysis, come to regression, double click. This will show up. Okay, this box will show up. In case someone is wondering what we want to run a regression. We want to run a regression. put the y range. Okay, so just erase that. Now, the y range is the deseasonalized values, or the y range are the deseasonalized values. So you highlight everything here as your y range. Why? Because when you go back, I'll put the formula. Okay, I'll put the formula so that we relate to the formula. Then the x range is your time period t. Highlight that as well. We want the labels. Yes, now actually, when highlighting the ranges, don't forget the labels. Put the labels. Okay, the labels, I mean that column, that cell which has got the labels. So do the same for the x. You put everything including the t. Now you have to make sure that you also mark or check where these labels there. Make sure that it's ticked up, it's marked. Then come to input range. Okay, the input range, it's more like you're telling Excel to say, I want you to put the answer here. I want you to put the answer from this cell going down. That's the input range. So click any cell. Let's click there. Meaning that our answers will start from this cell downward. Oh, not this. Then hit OK. Regression having trouble to offset input. Oh, because of this. Okay, so what we can do is just to put the input range somewhere else. Okay, let's put it here. Click OK. What's down? What's down there? What is disturbing our analysis? Let me remove this. Remove this somewhere else. So yes, the one that is causing trouble. Just put it here. So let's go back to data analysis. Then go back to regression. Let's restart to avoid errors. Let's put the y, which are this range. Go to the x values, which are this range. Labels marked 95% confidence interval, which is okay. Yeah, and then maybe to avoid complications, let's just use the new worksheet. Click OK, and then you have the output. Okay, so this is your regression output. So for those that have been looking forward to knowing how to run regression in Excel, this is what you do. Okay, so let's go back to our data. Yes, sir.
Can you repeat on how to y input range? I was kicked out.
Okay. So you come to data analysis. Then you choose the regression. Okay, you can either click once and then you click OK, or you can just double click. And then here it's saying input y range. Input y range. The y range are the deseasonalized values. Then here it's saying input x range. So the x range is the time period t. Highlight everything. Then make sure that the label box is marked. And then by default, okay, by default, get right, by default, unless otherwise, by default, the confidence interval is 95%, even in this data, even in eViews. Okay, the default percentage interval is 95%, or the confidence level is 95%. And then you have two options. If you want, you can put the output range where you are going to tell Excel to say, I want you to put the data. I want you to put the data, the output on the same page with the data. Okay, so in this case, let's use that one. It's gonna work. So it has worked. Okay, so this then becomes our output. Okay, is that fine? Is that fine? The one who was asking. So this guy is from this guy is from Mozambique are telling me to say we have there's an emergency meeting at 20:30. We're supposed to have a meeting with our sponsors, so I cannot ditch it. Otherwise I'll be kicked out. So I'll try by all means to do the interpretations of these, and then we finish the table in the next 16 minutes or so. So the summary output, this one just gives us the summary statistics or the regression statistics. The multiple R squared basically comes in if you are interpreting what we call a multiple regression. But this one is just a simple regression because we have got beta 1 and beta naught. You only have one statistic there, which is beta 1. Beta naught is not considered. You're going to understand this in econometrics, that basically when giving interpretation, beta naught carries less econometrical sense in terms of interpretation. Actually, it's useless. Okay, so the one that is considered is the beta 1, the slope coefficient. So the multiple R is useless in this case because we're dealing with a simple regression. But the R squared is making sense, okay, because we understand what the R squared stands for. Because the R, this one just to show us how accurate our regression is compared to the population regression formula. So in this case, you can say that 86.7% of our output, is falling on the correct regression equation, or 86.7% of our observations are lying on the population regression formula. And then the adjusted R squared, you're going to learn it this year in third year in econometrics 1, specifically in econometrics 1. And this one basically shows us how the regression equation changes as you add more explanatory variables. So in this case, we only have one explanatory variable, which is beta 1. But when you have got a multiple regression equation, you're going to have beta 1, beta 2, beta 3, beta 4, up to beta n. Okay, so the question is, for instance, if we're looking at how income changes, or how income changes, or consumption, for instance. Let me say consumption. So if you have got consumption as your dependent variable, you'll have income as one of the explanatory variables, that where consumption depends on income. You're going to have family size, because the higher the family size, the higher should be the consumption levels, right? You are also going to have other explanatory variables like gender. Maybe men consume more than ladies, or the other way around. So the question will be, if I add another explanatory variable, how will that affect my regression? How will that affect my interpretation? So that is captured by what we call the adjusted R squared. Okay. And then the standard error is nothing but the standard deviation. Okay. And then we have 16 observations, which is true, because we had highlighted 16 observations, if you remember. Okay. And then ANOVA is useless to you guys. Okay, so don't worry about this. This is just the analysis of the variance, which is of less practical purposes for econometrics. But then what we want is these two numbers. So this is the intercept. This is the intercept, and then this is our coefficient. Now, this means that our regression equation is small t is equal to, remember that by the beta naught plus beta 1 t, right? So now we can say is it's this, but why? Oh, I get it. 4.8649 space plus 0.1569 6923 small letter t. So this becomes our regression equation. This becomes our regression equation. So the reason why I'm saying this is useless, the 4.8 something something, what it means is that, for instance, I want you to understand why we are saying this is a nuisance. It's because in this case we're saying that when we're in period 0, we are going to have 4.8649 cells. But the question is, what is period 0? Okay? You understand that, right? Because time starts from time period t, where period t should be 1, which is now. Okay? Because no, period t less 1 is yesterday. Period t plus 1 is tomorrow. But in this case, we're saying that when t is 0, our cells will be 4.8649. But the question is, what is it? T0, what is this period? So that's why I'm saying that in econometrics, the beta node carries less, sense. Okay? Perfect. Again, what this 0.15692 mean is that if we change period by 1 unit, okay, our cells will increase by 0.15, which is just a change in y per change in x. Okay? We know this from calculus, right? You know this from calculus. Okay. I'm sure you also learned how to interpret in statistics. 2, 1, 2, I don't know. Either of the two. Alright? So now, what we want is to put values in this particular column. What we want is to put values in this particular column using our regression equation. Okay, using our regression equation, which is that one. So we go to the reason why we have gone data analysis is that we wanted to get these values here, so that we come up with our regression equation. Because we're going to use this regression equation to make or to find values for the trend. Okay, so quickly let's do that using that formula. So I've got 4.8649 plus, okay, plus 0.156923. What is t? Okay, someone's mic was on. Go ahead, ask your question.
Yeah. Yes. I'm still looking the numbers so that we look for.
Yes, we're looking at the numbers. Yes, we're looking at the numbers. Okay.
Sorry, I forgot the term. I mean where we will go to F4.
Oh, we wanted to look we are going to look the period. We see if it's going to work. Don't worry, we're going to look the period. Okay. Oh, let's just do that. Yeah, let's just do that. Then for us to work like that, then we'll have to put these values. So let's copy that one. We copy it and paste it somewhere. Maybe here. And let's call that beta node. Okay, and then let's have another one. Let's call that beta 1. We copy this one here. We copy it. Then we paste it here. Control V. But then what I want you to understand is that let's call that equal. So we have this one. Okay. Let's log it plus plus this one. We log it as well. We are multiplying that. Now I want you to understand this part. I'm following this formula here. This it's this one here, plus this, which is that one there. Then this is supposed to multiply by t. Where is t? T is all these numbers in this column, which are the periods. Which are the periods? Okay? Which are the periods? Alright. So, it's t is equal to 4.8649 plus 0. Multiplied by t. So, t is that one there, 1 in this case, right? So, multiplied by 1. Okay? Hit enter. What does that mean? This is now your trend using regression. So let's try to check if it's going to work. Okay, that's worked. Perfect. Okay, so what we've done is we've made a trend out of the regression formula, which is that one there. Okay, which is that one there. So we can call this the trend. Sorry for that. We can call this a trend. So the reason why we are finding the trend is that we want to understand the general movement of our data. Okay, after removing the influence of the season, after removing the influence of the seasonal component. Alright, and the other reason is that for us to make forecasts, we need the trend. Okay, for us to make the forecast, we need the trend, because the forecast is just the seasonal component multiplied by the trend itself. Okay, for us to make forecasts. Alright, so it's a time, time 16, hold on. So for us to make the forecast, I'll wait till they send the link. Yeah, just like I did yesterday. I'll wait till they send the link. Okay, so now, how do we make the forecast? The forecast is just the seasonal component multiplied by the trend. And we know. Okay, we know that the seasonal component is this one here. That's the seasonal component, right? Multiplied by the trend, which is this one, right? That will give us the forecast. So let's do that. This multiplied by this. Hit the enter sign. And then let's try to copy that. Oh Lord. Okay, so we have this as the forecast. But again, we are saying that this is the forecast, but check, we already have the data here, which means that these forecasts are useless. For us to say we are forecasted, we will have to forecast for the other year. Okay, we will have to forecast for the other year. The challenge with this is that even when you copy it somewhere, okay, this time, okay, cool. Okay, so which means that we will have to make forecasts for the following year. Okay, because you make forecasts for tomorrow, because already this data, we already have this data, which means that even this forecast carries less sense. We will need to make some forecast for the following year. So what are we going to do for us to do that? Okay, then we know that for us to make forecast, we will have to multiply the seasonal component, which is this, multiplied by the trend. Multiplied by the trend, right? So the only thing we need to do there is to extend the seasonal component. So which means that even this must then increase to the other year, which this year now is going to be 2024. Okay, so we should have an 18 there, a 19 there, and the period, period 20 there. So now, what we want is to make a forecast for period 2020, so for 2024. So the funny thing with his data is that, Excel is that the moment you put T there, the moment you put T, it's going to automatically run a regression on your behalf and fill this part for the regression. Okay, so because you've put these, because these are periods, so Excel has known that this T goes into a regression. So the moment you log in numbers there, it calculates for you. Okay. But we know that for us to make forecast, we need the T and the seasonal component. We need the T and the seasonal component. And we know that the seasonal component, the seasonal components are these ones. For each particular quarter, there is a specific seasonal index, right? So what we can do is the same thing. We just copy the first 4. Okay, we copy the first 4, and then we drop them here to fill that blank space there. Then the next thing will be just to fill in the remaining part. Just to fill in the remaining part, which is this part here. So what we do is just fill there using the fill handle, which means that we have now made forecast for 2024 using the previous data. What is this previous data? The previous data is data from 2020 to 2023, which has helped us to make forecast for 2024. Alright, is this fine? Are we together this far?
Mr. Makambo, somebody talked about locking the values.
We already locked the values. It means that everything that is coming.
You mean using the F4 function?
Yes, sir. Yes, sir.
Is it control F4 or shift F4?
No, it's just to click F4.
Oh, okay.
When you do that, your values should change into dollar signs.
Everything is clear except about the question somewhere.
Okay, go ahead.
Yeah, when you pick the specific seasonal
indices.
Yes, but you want to pick the first 4. Can you pick any 4 from any year? Or pick from 2020?
Okay, so I've picked
21 or...
If you can check properly, the pattern is, there's a pattern that we are following here. So, as you can see, every first quarter has got that value. Check, 2020 quarter 1, you have got that value. Go to 2021, you have got the same value. So, there's a pattern. 4. So, they follow that particular pattern. That's why I've just copied the first 4 and plugged them in 2024. Because I know that 2024 quarter 1 will have the same value as 2020 quarter 1.
Yeah, I see.
Yeah.
Okay, thank you so much.
You're welcome. Okay, so what we've done today is exponential smoothing and forecasting. Okay, I'm sure you've done this in statistics 1 or 2, statistics 2. Yeah, but it's important for us to use technology, because assuming you're employed by Absa Bank, they'll give you, let's say, 1 million entries. And you want to use a calculator, my friend, are you okay? So you'll have to use Excel, you'll have to use Stata, maybe you'll have to use SPSS, eViews. The choice is yours if they're not going to guide you. So if you know that Excel is better, use Excel, put the dataset, do the analysis, do the presentation. Do the presentation properly with a nice suit. You are promoted, my dear. Alright, so that's the reason why we have struggled like this for us to do this. Alright, do you have questions? Do you have questions?
Yes, Mr. Makambo, question.
Go ahead.
Yeah. Remember that time when we looked at exponential smoothing?
Yes, sir.
Yeah, my question is on the smoothing constants.
Yes, sir.
In practical situations, do we continue using the same 0.4, 0.6, or maybe we have to change?
In practice,
what factors do we put into? What factors do we take into account?
Okay.
when choosing those values?
Okay, thank you. So the smoothing constant is very important. So what you do is that tomorrow I'll show you how, in practical terms, how we get those particular values. We don't just choose them randomly. Okay? We don't just choose them randomly. So because of time, I have to go for this meeting. Guys, I can't miss. Please bear with me. My aim was to go up to, to compensate for that 30 minutes for yesterday, but there's nothing I can do. So what I'll do is, so I know that now I owe you an hour. 30 minutes for yesterday and 30 minutes for today. So I owe you an hour. I'll surely compensate for this. Is it an hour? No. I still owe you 30 minutes, right? Yeah, I owe you 30 minutes for yesterday, which I was supposed to compensate for today. So I've taken that into consideration. It's not my fault. You know that I really want us to finish this, but it's something that is beyond my control. So tomorrow, the first thing, I'll show you how to get in practical terms, what we do for us to get those values. We don't just get them arbitrarily, randomly. No. There's some gymnastics that we do. Those ones that, it's rare anyway, that when you're carrying out a research, for instance, they're going to give you the constants. Why should they give you? They know you're a statistician. You have to know how to get what we call the best damping factor. So you have to get the best damping factor. So I'll show you in Excel how to get the best damping factor tomorrow. Alright, Christoph.
Thank you so much, Mr. Matambo.
Okay, you're welcome. Alright, so if there's no question, I will have to let you go.
Just one more thing, please.
Yes, Peter.
Remember to help us with the recordings for revision's sake.
Okay.
Because the recordings will be very much helpful as well.
Yeah, so